Welcome to our educational video on GPT, our Generative Pre-trained Transformer. Today, we're going to take a closer look at what GPT is, how it works, and what makes it so powerful. First, let's start by defining what GPT is. GPT is a state-of-the-art language model developed by OpenAI. It is an unsupervised deep learning model that is trained on a large corpus of text data to generate human-like text. This means that GPT can complete a given prompt or continue a given text in a way that is often indistinguishable from text written by a human. Now, you may be wondering, how does GPT accomplish this? The key is in the architecture that it's built on, the transformer. The transformer architecture was introduced in 2017 in the paper, Attention is All You Need, by Google researchers. It uses self-attention mechanisms to process input sequences, allowing the model to weigh the importance of different parts of the input when making predictions. This makes the model more efficient and effective at handling long-term dependencies and large input sequences, which is crucial for understanding and generating natural language. The transformer architecture is a marked departure from traditional architectures like RNNs and LSTMs. RNNs and LSTMs process input sequences one step at a time, meaning that the model can only access previous steps when making predictions. This can make them less effective at handling long-term dependencies. The transformer architecture, on the other hand, processes the entire input sequence simultaneously, allowing it to more effectively capture long-term dependencies. It's worth noting that GPT has undergone several updates, with different versions being released over time. GPT-1 was the first version, which was followed by GPT-2 and GPT-3. With each version, the model has become larger and more capable. The latest version, GPT-3, has 175 billion parameters, and has been trained on a diverse range of internet text, allowing it to perform well on a wide range of language tasks with minimal fine-tuning. That's a brief overview of what GPT is, and how the transformer architecture enables its capabilities. In the next part of the video, we'll dive deeper into how GPT is pre-trained and fine-tuned, as well as some specific applications and use cases for the model. Welcome to the second part of our educational video on GPT. In this segment, we're going to explore how GPT is pre-trained and fine-tuned, and discuss the advantages of this approach. GPT is pre-trained on a large corpus of text data, which enables it to learn the underlying patterns and features of the language. This pre-training step allows GPT to perform well on a wide range of natural language processing tasks, even when it is fine-tuned on a small amount of labeled data. One of the key advantages of pre-training is that it can significantly speed up the training process for new tasks. Because GPT has already learned many of the underlying patterns and features of the language, it can be fine-tuned on a new task using a small amount of labeled data. This results in faster training and better performance compared to training a model from scratch. Fine-tuning GPT on a specific task can be done in several ways. One of the common method is transfer learning, where the pre-trained model is fine-tuned with a task-specific dataset. Another method is fine-tuning on a specific task using the pre-trained weights and adding new layers, architectures or even architectures on top of the pre-trained model. The selection of the fine-tuning method depends on several factors like the size of the labeled dataset, the complexity of the task, the computational resources available and the desired performance. It's also worth noting that GPT can be fine-tuned for a variety of specific tasks, including question answering, text classification, and machine translation. In the next segment, we'll take a look at the capabilities of GPT in generating text and understanding language, and see how it's used for different applications in natural language processing. GPT has the ability to generate highly realistic and coherent text. It can complete a given prompt or continue a given text in a way that is often indistinguishable from text written by a human. This makes GPT a powerful tool for a wide range of natural language processing tasks, including text completion, translation, summarization, and more. One of the most common use cases for GPT is in chatbots. By fine-tuning GPT on a specific conversational task, chatbots can generate human-like responses that are coherent and contextually appropriate. Content creation is another use case. GPT can be used to generate articles, blog posts, and other types of written content. GPT is also used in text completion tasks such as writing assistances in question-answering applications where it can complete a given prompt or answer a question based on given context. The text generation process in GPT can be achieved through several methods, One of the popular method is through sampling and the other one is through beam search. Sampling-based text generation method randomly generates text based on the learned probability distribution, which can lead to more creative and diverse output. Beam search-based method on the other hand generates text based on a specific set of rules and can produce more accurate output but less diverse. The choice of which method to use depends on the use case and the desired trade-off between creativity and accuracy. In the previous segment, we discussed GPT's ability to generate text. In this segment, we'll focus on another key capability of GPT, language understanding. GPT is able to understand and process natural language input through its use of the transformer architecture and the attention mechanism. The transformer architecture allows GPT to process the entire input sequence simultaneously, allowing it to more effectively capture long-term dependencies, and the attention mechanism allows the model to weigh the importance of different parts of the input when making predictions. This language understanding capability makes GPT useful for a wide range of natural language processing tasks. For example, GPT can be fine-tuned for question-answering tasks, where it can generate accurate and contextually appropriate answers based on a given prompt. It can also be used for text classification tasks, such as sentiment analysis and spam detection, where it can accurately classify text into different categories. GPT can also be used for machine translation tasks, where it can translate text from one language to another with high accuracy and fluency. To understand the text, GPT uses tokenization, where the input text is broken down into individual tokens, typically words or subwords, which are then passed through the model. These tokens are then processed by the attention mechanism and the other layers in the transformer architecture to generate output. Additionally, GPT uses language modeling, where the model is trained to predict the next word in a sentence based on the previous words, which helps it to understand the context and meaning of the input text. In the next segment, we'll discuss some advanced and cutting-edge applications and use cases for GPT, as well as its limitations and future developments. One area where GPT is being explored is in dialogue systems. GPT-based dialogue systems are able to understand and respond to user input in a conversational context, making them useful for a wide range of applications such as customer service, personal assistance and more. GPT can also be used to create language models for specific industries. For example, it can be fine-tuned for legal, medical or financial industries where it can perform specific tasks like document summarization, legal document drafting and financial statement summarization. Another important aspect to consider when discussing GPT is its potential ethical and societal impact. GPT, being a deep learning model, can replicate the biases present in the data it is trained on. This can lead to unfair or harmful outcomes, such as the generation of biased or discriminatory text. Additionally, the increasing capabilities of GPT and similar models raise concerns about the impact on employment in the future of work. It's important to be aware of these ethical and societal implications when deploying and using GPT, and take steps to mitigate any negative effects. It's also worth noting that, despite its capabilities, GPT does have limitations. One limitation is that, while GPT can understand and generate text at a high level, it doesn't possess a true understanding of the world or the ability to reason like a human. Additionally, GPT can suffer from repetition and lack of creativity in its generated text, and the model is computationally expensive and requires large amounts of memory and computational resources. Despite these limitations, the future of GPT looks promising. Research is ongoing in areas such as model compression, improving the robustness of the model, and exploring new ways to use GPT's capabilities. As the field of natural language processing continues to evolve, we can expect to see GPT and similar models being used in new and exciting ways. Advanced applications of GPT include GPT-based dialogue systems, which can understand and respond to user input in a conversational context, and can be used in customer service and personal assistant applications. GPT can also be used to create language models for specific industries, such as legal, medical or financial industries, where it can perform specific tasks like document summarization, legal document drafting, and financial statement summarization. The ethical and societal impact of GPT must be considered, as the model can replicate biases present in the data it is trained on, leading to unfair or harmful outcomes. Additionally, the increasing capabilities of GPT and similar models raise concerns about the impact on employment in the future of work. However, GPT also has limitations such as lack of true understanding and reasoning abilities, repetition in generated text, and high computational cost. Researchers are working on addressing these limitations through techniques like model compression and robustness improvement, and exploring new ways to use GPT's capabilities. These developments are expected to bring GPT to new and exciting applications in the future. In this educational video, we have covered various aspects of GPT, a state-of-the-art language model developed by OpenAI. We started with an introduction to GPT and the transformer architecture, which is the key enabler for GPT's capabilities. We then discussed how GPT is pre-trained and fine-tuned, and the advantages of this approach. We also explored GPT's text generation capabilities and its use in various natural language processing tasks such as chatbots, content creation, text completion and more. We also went deeper into GPT's language understanding capabilities and how it uses tokenization and attention mechanisms to understand natural language input and how it can be used for tasks like question answering, text classification and machine translation. Later on, we discussed some advanced and cutting-edge applications of GPT, such as GPT-based dialogue systems, GPT-based language models for specific industries and the ethical and societal impact of GPT, as well as limitations of the model and future developments. Overall, GPT and the transformer architecture have had a significant impact on the field of natural language processing, allowing for the creation of highly realistic and coherent text and the ability to understand and process natural language input. If you're interested in learning more about GPT and related topics, there are many resources available online, including the GPT paper by OpenAI, tutorials, and blog posts on the OpenAI website, and research papers on the transformer architecture and other related topics.